We have a very beautiful geometry question to solve. Welcome back to my channel. This is not done to spell, please. So in this particular video, we are asked to find the area of this big circle. Now let's call this point A. This meeting point, let's call it N. Let's call this point B. Okay, so the question says that we should find the area of the big circle. Let's call this point C. Okay, all right. Now we can see that CB is a tangent and AB is a secant. Okay, so using tangent secant theorem, we will have that CB squared will be equal to NB multiplied by AB, sorry. So we have CB squared is equal to NB is 9 and AN is 16. Sorry, AB is 16 plus 5. (16 plus 9). So we have CB squared is equal to 9 multiplied by 25. Now let's take square root of both sides. We have square root of CB squared is equal to square root of 9 multiplied by 25. So this will remove this. We have CB is equal to square root of 9 multiplied by square root of 25. So CB is equal to 3 multiplied by 5. CB is equal to 15. So let's write that 15. If you are just seeing us for the first time, okay, it's time to click that subscription button and turn on the notification bell so that you don't miss our videos. Yeah, so that anytime we upload a new video, you'll be first to be notified. Give us a thumbs up if you love what we are doing. If you don't, we are open to corrections. So please give us your corrections on the comments and we abide by that. All right. Now that we have found CB to be equal to 15, let's join C to N. All right. So if we do that, we will have this. And I want you to see that let's drop a straight line through the point of intersection of these two circles. I'm sorry, this circle is supposed to touch each other at just a point. Okay, so please pardon the drawing. So if we drop a perpendicular, now you can see that let us discuss a tangent theorem. External tangent theorem. Now this theorem says that if a circle with two tangents that meet at a point, let's call this point P. Let's call this point A and this point B. This external tangent theorem, please, this is supposed to be a straight line. This external tangent theorem states that AP is equal to BP. That AP is equal to BP. So that simply means that looking at this from here, we can see that if we call this point, their point of intersection O, you can see that O is the external point and CO and NO are tangents. So this means that CO should be equal to NO. Similarly, ON should be equal to OB. All right. Now you can see that we have triangle CON and the two sides are equal. Therefore, triangle CON is an isosceles triangle. And if this is an isosceles triangle, the base angles are equal. So we can say if this is alpha, then this angle is alpha as well. Similarly, if this is beta, this angle is beta as well. Now, what we have now is triangle CNB. Let me draw it out. So from here to this line is alpha, and from here to here is beta. Okay. All right. So let's draw triangle NCB. Triangle NCB. So we have this, we have this, we have this. This is N, this is C, this is B. Then you can see that here is alpha and beta. All right, N is alpha plus beta. Your C is alpha and your B is beta. So this alpha and this is beta. The sum of angle in a triangle is 180 degrees. So we can say that alpha plus beta is equal to 180 degrees. So alpha plus alpha is 2 alpha. Beta plus beta is 2 beta. Is equal to 180. So let's factorize 2 brackets. Alpha plus beta is 180. Now dividing both sides by 2, we have 2 brackets alpha plus beta is equal to 180 divided by 2 divided by 2. So 2 we divide 2 and 2 we divide this to give us 90. So you can see that we have that alpha plus beta is equal to 90 degrees. So alpha plus beta is equal to 90 degrees. So that means here, from here to this place is 90, meaning that this remaining part is 90 as well. Now let's join A to C. Okay, so if we join A to C at point C, being that this is the point of contact between this straight line and the tangent, this is 90 degrees, right? Okay, so we have triangle ACB. So in triangle ACB, let's draw that. So this is A, this is C, and this is B. CB is 15. Okay, you can see that. Then AB is 16 plus 9, which is 25. And AC is unknown. We don't know it yet. So using Pythagorean theorem, we have that 25 squared is equal to AC squared plus 15 squared. Now if we transfer this to the other side, we have 25 squared minus 15 squared is equal to AC squared. Remember that A squared minus B squared is equal to A minus B multiplied by A plus B. So we have 25 minus 15 multiplied by 25 plus 15 is equal to AC squared. 25 minus 15 is 10. 25 plus 15 is 40 is equal to AC squared. That means 400 is equal to AC squared. Take square root of both sides. And we have square root of 400 is equal to square root of AC squared. So this will remove this, and we have that 20 is equal to AC. So we have AC is 20. So this is 20. Now we just confirm something. We can see that this angle here is 90 degrees. And remember that in a circle of center 0, a straight line that passes through the center, which is the diameter, makes an angle of 90 degrees with the circumference. So this implies that AC is the diameter of this circle, even though this is not drawn to scale. So it doesn't really look like that, but that is because this is not drawn to scale. So AC is the diameter, and if AC is the diameter, AC is the diameter, which is 20 cm or 20 units, and the radius then of the circle should be 20 divided by 2, which is 10 units. All right. Therefore, the area of the circle, which is pi r squared, will be equal to 22 over 7 times r is 10, so 10 squared. So you're going to have, let me leave it in terms of pi. So you're going to have 100 pi square units. Thank you for watching. See you in my next video. Bye.